In this video, we want to solve some questions involving indirect proportion or inverse proportion. Now, whenever you hear indirect or inverse proportion, this picture comes to mind. On a seesaw, whilst one person is going down, the other is going up, and whilst the other is going up, the other is coming down. This is what happens in indirect proportion. So we use indirect or inverse proportion when two quantities vary such that as one increases, the other decreases at the same rate. A typical example is a number of people working at a specific rate, and we compare that to the time that they use to complete the work. So for example, if I have two men completing a job in 5 minutes, if I increase the number of men to, let's say, 10 men, I should expect that the time that they take to finish the work will be much less than 5 minutes. So this is a typical example of indirect or inverse proportion. Let's look at some examples of indirect or inverse proportion in real life. So we use indirect or inverse proportion when we have a number of workers on a job and the time taken to complete the job. We can also use indirect proportion when we have a situation whereby there is a number of people eating or some animals feeding and the time taken for them to finish the food. Also, speed compared to time is an example of indirect proportion. When you increase the speed of, let's say, an athlete or a car, the time taken to cover a specific distance will be much less. And if you reduce the speed, the time taken will also increase. So that's a typical example of indirect proportion. And another example is pressure exerted on an object and the volume of the object. So let's assume we have an object like this, and then we exert pressure on it. The more pressure we exert on it, the object will shrink in size. So as the pressure increases, the size of the object decreases. So that is an example of indirect proportion. Also, the distance and level of sound or the brightness of light. So as you get closer to a source of light or a source of sound, the sound is much louder or the light is much brighter when the distance is short. But when the distance is increased, the sound or the brightness of the light reduces. Also, a number of people and an amount that each person gets after being shared. So if 5 people are sharing, let's say, 100 cedis, each person would get 20 cedis. But if we increase the number of people, let's say 10 people are sharing the 100 cedis, then the amount that each person gets is less while the number of people increases. So these are some typical examples of indirect or inverse proportion in real life. Let's solve some questions involving indirect proportion. Example 1. 4 people can paint a fence in 3 hours. A. How long will it take 6 people to paint it? And B. How many people are needed to complete the job in half an hour? To solve this, we need to identify the units that we are given in the question. We have 4 people working in 3 hours, and the first question is asking us for how long. So that would be in hours, and we also have the people. So let's write out the proportion. We know that 4 people will complete the job in 3 hours. And so how many hours will it take 6 people to complete the same job? So let's represent that with an X. And in indirect proportion, we need to make some changes here. Otherwise, if we go ahead and do the cross multiplication, the time will increase. But in reality, it's supposed to be less than 3 hours because we have increased the number of people who are working. So in writing the fraction, I'm going to maintain one of the ratios, and then the other ratio I will do a reciprocal. Okay, I'll exchange that. So I have to indicate here that this is an indirect proportion. So since I've indicated that it is an indirect proportion, I'll maintain the ratio for the people, which is 4 out of 6, will be equal to x out of 3. So I have x over 3. So now I can do my cross multiplication and then go ahead and solve it. So I have 6 times x is equal to 4 times 3. When I divide both sides by 6, I'm going to get x is equal to 4 times 3 all over 6. Since the numbers are not too huge, I can multiply and then continue. So I have 12 divided by 6. And my answer will be equal to 2. So I have x is equal to 2. So therefore, 6 people will paint the fence in 2 hours. Okay, so we can indicate it here. So that is the A part of the question. Now with the B part of the question, we are being asked how many people are needed to complete the job in half an hour. So we are going to use the same ratio that we were given in the question. We know that 4 people will paint the fence in 3 hours. So our 4 people complete the job in 3 hours. So how many people? So let's represent that with an x. X people can complete the job in half an hour. Now half an hour is 30 minutes, but we don't necessarily need to change to minutes because we already have the first quantity in hours. So I'm just going to write the half an hour here, and I would prefer to write it as a decimal, which is 0.5 hours. So now I'm going to effect the change. I'm going to do a reciprocal on one of the ratios and indicate here that it is an indirect proportion. Okay, so anyone who is going through the solution will know why you are doing that change. So I'm going to maintain the ratio for the people, but I'm going to do a reciprocal on the ratio for the hours. And you can choose to change that of the people and maintain the hours, or vice versa. So any of them will work. Okay, so if you decide to change that of the people, you get x over 4 is equal to 3 over 0.5, and you get the same answer anyhow you go about it. So we do our cross multiplication and we get 0.5 times x is equal to 4 times 3. When I divide both sides by 0.5, I'll get x to be equal to 4 times 3 all over 0.5. So this gives me 12 over 0.5. Now I have a decimal here, and I should try and then get rid of the decimal. So this is what I'm going to do. The decimal place is only 1. So I'm going to multiply the numerator and the denominator by 10. So when I do that, this decimal point will move to the right once, and then I'll get 5.0. And 12 is the same as 12.0. So when I multiply by 10, the decimal point moves to the right once, and then I'll get 120. So 12 over 0.5 is the same as 120 over 5. So now I can divide. 5 will divide itself once, and then it will divide 120 24 times. So I have my answer to be equal to 24. So therefore 24 people will paint the fence in half an hour. Okay, so that's the solution to the question. Let's try another example. In this question, it says that if 20 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? So we check the units and we have workers, and they are asking for how many workers, and then we have the time in hours and hours. So we can go ahead and write our proportion. So we know that 20 workers will complete the work in 48 hours. So how many workers can complete the work in 30 hours? Okay, so if you are a building contractor and you are working with time, this will give you a good idea of how many workers you need in order to meet the deadline. So we are going to use our indirect proportion, since this is number of workers against time. So we are going to do a reciprocal on one of the ratios. So I'm going to maintain the workers, so that will be 20 over x is equal to 30 over 48. So now I can do my cross multiplication, and I'll have 30 times x is equal to 20 times 48. Okay, so it can be either way around, 48 times 20 or x times 30, and either of them can be on the left or on the right. When I divide both sides by 30, since I'm looking for x, I'll get x is equal to 20 times 48, all divided by 30. So I think the numbers are huge, so I can divide, can cancel this 0, and I know that 3 can divide 48 16 times. So 3 will divide itself once, and it will divide 48 16 times. So I have 2 times 16. Okay, so that is what I have remaining. So my x is equal to 2 times 16, and that will give me 32. Okay, so 32 workers will be needed to build a wall in 30 hours. 32 workers will be needed to build the wall in 30 hours. Okay, so always remember to do the indirect proportion when you identify it in a question.